Okay, can you hear me now? Okay, great. Okay, so in order to do this problem, we're going to do the opposite of multiplying by 3. In this case, the opposite of multiplying by 3 right here. We can see 3n is really 3 times n. So to do the opposite of that, we're going to divide both sides by 3. And that would give us n minus 4. Here's another example where we're actually dividing by 3. To do the opposite of dividing by 3, we'll end up multiplying both sides by 3 to get rid of the division of 3. We're going to typically perform the opposite of the operation in the equation to get rid of it. So anytime we want to get rid of something, we just do the opposite of whatever it's doing. If it's subtracting, we add it. If it's dividing, we multiply it. Okay, if it's adding, we subtract it. Okay, and so that'll give us 36. And here's the scale that we were referencing earlier to keep it balanced. Okay, so here we have 3x plus 2 equals 5. Okay, so what we'll do is we'll take 2 off of both sides. And then at that point, we will have 3x equals 3. And what that means is every x is equal to 1 point. So for every x, we take away 1 until we're left with 1x and 1, 1. Here, if we're going to solve this one, we're looking to get rid of two things. We're looking to get rid of the addition of 3 and the multiplication of 2. So these are the things that we're going to look to get rid of. So in order to get rid of the addition of 3, we'll have to subtract that 3. In order to get rid of multiplication of 2, we'll have to divide by 2. So we'll subtract by 3, and then we'll divide by 2. And that will leave us with n equals 4. And with 3x plus 5, we're looking to get rid of the addition of 5 and the multiplication of 3. And so to do that, we got to subtract by 5 and divide by 3. So we'll divide both sides by 3. And that'll give us x equals 4. And here's another one for us. Okay, so we're going to add 3 to both sides. And then finally, we'll divide both sides by -2. Now, it's important to remember that whatever we do to one side, we have to do to the other side in order to keep the scale balanced. And that will give us x equals -6. Of course, we can go back and verify that. -2 times -6 is positive 12. And 12 minus 3 is 9. All right, here's another one. Okay. In front of the subtraction, we can't see the number in front of x, so it's going to be 1. Okay, 1 is silent a lot in math, so that's important to remember. So we're going to subtract 2 from both sides. Then we're going to multiply or divide both sides by -1. Either way, it'll work. That's going to give us x equals -2. Now, fraction problem is performing two operations. It's dividing by 3 and it's multiplying by 2. So, I mean, we could do that step by step. We could divide both sides by 3. Then we could turn around and, we could multiply both sides by 3. Then we could turn around and divide both sides by 2. Or we could do it in one step, much like what the fraction does. We could multiply both sides by the reciprocal of 2/3, which is 3/2, which is what we end up doing. Okay, and then we cross cancel our way through the problem. We can see the 3's cancel out, the 2's cancel out. We cancel here and we're left with 8. And the final answer is x is equal to 24. On this problem, we're simply going to add 3 to both sides and then divide by 4. All we're trying to do is get rid of everything around the x. And the way we do that by doing the opposite of whatever it's doing. We're subtracting by 3, we add 3. Okay, we're going to do it to both sides. You always have to do it to both sides in order to keep the scale balanced. And then we'll divide both sides by 4. And that will leave us with x equals 2. Okay, so we have more examples here. Okay, the first one will divide both sides by 4. And the second one will divide both sides by -12. And then the last one will subtract 23 from both sides. And then we'll divide both sides by -1.
See, that's what I'm saying. They're not
Okay, and back to our balancing scale again. Okay, we can take 3 from both sides here. And then we can take 3 x's from both sides. And then for each x, we'll have each x is equal to 2 1s. So we can take 2 1s. And we're left with x equals 2. Okay, here's a more complex problem. With this problem, before we start trying to get rid of stuff, we need to combine it. So here we can see we can take the 2x and the 3x and add those together on the right side, on the left side. On the right side, we can take the 11 and the -6 and bring those together. And so that's going to give us 5x minus 5. And then, of course, 11 minus 6 is 5. 5 plus 4x. From there, we can either subtract 5 or add 5 to both sides. And so that's going to leave us with 5x equals 10 plus 4x. Then we can subtract 4x from both sides. And then that'll leave us with 1x equals 10. On our next problem, we'll use the distributive property to combine things. 3 times x and 3 times 5. 3x minus 15 equals x plus 5. And from there, we'll add 15 to both sides. And from there, we'll subtract x from both sides. And then we'll divide 2 from both sides. And then that's going to give us x equals 10.
Before in my CMA class,
in this equation, we have to remember that there's a silent 1 here. So we want to go ahead and put it in. So when we start distributing, we can see that we're distributing a -1 throughout the parenthesis in order to remove the parenthesis. -1 times 3 and then -1. That's going to actually be -1 times 1. There's another silent 1 here as well. So -1 times -1 is going to give us a positive 1x. And then we combine the 2x and the 1x. I'm going to put another 1 here because 1's silent a lot in math. Just seeing the 1 helps us to understand what we're supposed to add together. So it's going to give us 3x minus 3 equals 6x. We can subtract 3x from both sides. We're going to be left with -3 equals 3x. From here, we'll divide 3 from both sides, okay, in order to eliminate the 3 next to the x. And that's going to give us x is equal to -1. And here's another one where we have variables on both sides. We'll add 2x to both sides. when you got to get rid of an x, you always want to get rid of the smallest x. Okay, so a negative 2 is smaller than a negative 1. If you get rid of the biggest x, you're probably going to be swimming in negative numbers. Okay, now it's not to say that the problem can't be solved at that point. It can, but it's just going to create extra work. Less work, the better. Okay, and so we add 2x to both sides. That's going to give us 3 plus x equals 7. We'll then subtract 3 from both sides to get the x by itself. That's going to mean x is going to equal 4. Here we have a fraction equation. Okay, fraction equations. They're still linear equations. However, we want to find an equivalent equation that doesn't involve fractions. So what we'll be looking for is the LCD between 2 and 3, which that's going to be 6. So if we multiply everything by 6, we'll be able to cross cancel our way through this problem. Okay, cross cancel in the sense 6 divided by 2 is 3, and 6 divided by 3 is 2. Yeah. And notice how we multiplied the 6 by the 5 on the other side, even though it was a whole number. So that's a common mistake that people don't make. They multiply the LCD, the least common denominator between the 2 and the 3, by the fraction, but sometimes they forget about the whole number. Yeah. And so when we get down to it, we end up with 3x, 2x, and 30. So by cross canceling, we get here faster. 5x equals 30. We'll divide both sides by 5. And then x is going to equal 6. Okay, we have another fraction equation. What we're going to do is find the LCD. In this case, it'll be 12. Because 3 times 4 is 12. And then we're going to multiply everything by 12. And once again, we can cross cancel our way through this. 12 divided by 3 is 4. And 12 divided by 4 is 3. So now we got 4x plus 3x. These other steps, if we cross cancel, we can skip. And we come out right here. Okay, then we add the 4x and the 3x together and we come up with 7x. Divide both sides by 7. Uh-oh. All right, hopefully everybody can still hear me. Okay, so we divide both sides by 7 and we end up with x equals 24. Here's another fraction equation. The LCD here is going to involve that variable x. Okay, so in this case, it'll be 6x because 6 is a multiple of 2 and 6. So we'll multiply everything by 6x. Okay, and then we can cross cancel our way through this one as well. 6 divided by 2 is 3. X divided by x is 1. 6 divided by 6 is 1. And that will allow us to skip all of these steps and come straight here. So 3x times 1 is 3x, 6 times 1 is 6, and x times 1 is x. Okay, anything times 1 is itself. So that's how we were able to just kind of get through this. We'll subtract x from both sides because we always get rid of the smallest x first. It's going to give us 2x. And then 2x equals 6. We'll divide both sides by 2. And x will equal 3. Inequalities are similar to equations. There's only one exception. Okay, so everything that we just talked about, equations, we'll use on inequalities. Okay, except for one exception or one rule, and we'll see that a little later. Okay, we're going to do the same thing to both sides. We'll always end up eliminating all the numbers around the variable. Okay, here's our inequality symbol: greater than, less than, greater than or equal to, and less than or equal to. So here's a word problem involving inequalities. The distance x is more than 100 miles to Boston. Okay, and we can see that as x is greater than 100. If x is less than 100 miles to Harvard, that's going to be x is less than 100. Now, at most does not mean greater than, it means less than or equal to. And at least does not mean less than, it means greater than or equal to. Okay, so here's a problem. Now, this problem gets solved the same way an equation does. We simply subtract 3 from both sides. And that gives us x is less than 4. For the second inequality, we simply divide 3 from both sides. And that gives us x is less than 4. For the next inequality, we're going to multiply 2 by both sides. Okay. Or we can multiply both sides by 2 over 1. We'll get the same outcome, which is going to be 18.
Oh yeah.
There we go. So we have x is greater than 18. Okay, now here's the exception to the rule. Anytime we divide or multiply both sides of an inequality by a negative number, it causes the inequality sign to reverse. So if it was greater than when we started, when we finish it will be less than.
They took me out. They gave you, and they took me out. They only needed one man. Yeah, but they need your man. I know that. That's the thing. I don't teach fractions.
So here we go.
I don't teach addition.
So we have
They're supposed to already know how to do that.
5x plus 3 is less than 2x plus 15. Now, we don't have any negative values in this problem, so we don't have to worry about that rule right now. We'll simply subtract 3 from both sides, subtract 2x from both sides, and then we'll divide 3 from both sides. Here's the problem where we have to consider the rule, and the reason why is because we have a negative 2 that's being multiplied. When we divide both sides by that negative 2, it's going to cause that inequality to reverse. So what we want to do is we want to watch this inequality sign right here when we do that division. Okay. And right down here we can see the reversal occurring right there. And that's simply because we divided both sides by a negative number. So that's the one difference between equations and inequalities. All the other steps will be the same.
What they need to do is take physics out, put CMA in, and move you down.
And of course, we're restating the rule again. Inequality sign is reversed when we multiply or divide by a negative number. Okay, so here's another one. Now, because we're dividing, when we have to get rid of this division of a negative, we have to multiply. So that's going to be a reversal here. And of course, we can see the reversal occurring right here. And that's going to give us x is less than negative 15 when we finish. All the stuff that we use to solve equations, we'll use to solve inequalities. The only difference is that one extra rule that inequalities have. That is where when we multiply or divide both sides by a negative, it causes the inequality to reverse. All right, that is the end of our presentation for the variables, exponents, equations, and inequalities. Okay, at this point, we're going to leave the remaining 15 minutes for a Q&A session. Okay, this session is recorded, so if you missed any parts of it because you're registered for this CMA, go to training, you'll receive a copy of the archive, okay, which typically gets put into the go-to training recordings. And if it's bigger than 5 MB, then I end up putting it on YouTube. But either way, you'll get the link. Okay, any questions? Okay, if no questions, that's going to conclude our go-to training. Once again, I'm sorry for our technical problems. I have a loaner Mac, and so it's not as reliable as my Mac. Okay, but if you don't have any questions about the go-to training today or Alex, you're free to go. You're welcome, Lauren. You're welcome, William.